This chapter 4 illustrates basic FX applications involving outright forwards, FX swaps, and towards the end, an instrument known as a par forward. Assume first that a US company is expecting to receive 10 million euros in 6 months from sales of its products into Europe. The company is worried about the risk of the euro weakening before the payment date and wishes to hedge this exposure. The trading screen appearing now provides the FX spot rate along with the forward points for standard maturities. Since the company is expecting the receipt of euros in 6 months, it is effectively long euros against dollars 6 months forward, and therefore the treasurer will need to establish a short 6-month euro-dollar forward position as her hedge. The treasurer would therefore have to trade on the bid side of the spot quote, and since the points are quoted in descending order, would have to deduct the bid side 6-month forward points from the spot. This gives rise to an outright forward rate of 1.5474. From the moment she executes the short forward hedge, the treasurer has become immunized in the aggregate to any fluctuations in the euro-dollar spot rate, since she has locked in a fixed amount of US dollars that she will receive under the FX forward hedge, irrespective of the actual spot rate at that time. More specifically, on the 6-month value date, the company receives 10 million euros from its European customers and delivers them to the bank under the forward. The bank in turn delivers $15.474 million to the company, achieving the exact effect intended under the hedge. We next illustrate a common end-user application of FX swaps by financial institutions expanding into foreign markets. Suppose the Turkey branch of a US bank needs to borrow Turkish lira in order to fund its loan portfolio, but does not have the ability to access directly the local currency funding markets. The bank instead issues a 6-month term deposit in US dollars. Inside or outside Turkey, it does not matter for our purpose, and immediately converts the proceeds into Turkish lira at the FX spot rate. With this currency in hand, the bank is now able to build a domestic loan portfolio in local currency, but finds itself with a significant currency mismatch between its loan portfolio in Turkish lira and the associated dollar liability funding it. A sharp fall in the Turkish lira against the US dollar would devastate any lending margin the bank is earning under its loan portfolio and potentially even erode some or all of the principal. The bank therefore needs to hedge the anticipated repayments under its Turkish lira loan portfolio back into US dollars via the FX forward market to ensure it has enough US dollars to redeem its liability at maturity. In aggregate, the bank has executed a spot sale of dollars and a forward purchase of dollars, which of course can be combined simply into a 6-month FX swap. We conclude by describing the pricing and use of an FX par forward. Suppose that on September 16, 2005, a US company completes sales to a Brazilian company, and that the Brazilian company has promised payment in 4 equal quarterly installments of 10 million Brazilian reals each. The US company would like to lock in a definitive exchange rate for each receivable to eliminate its exposure to fluctuations in the exchange rate. The company could presumably execute a series of 4 long dollar real forwards at the prevailing rates for maturities of 3 months, 6 months, 9 months, and 1 year. We turn to the spreadsheet labeled Par Forward to show the pros and cons of this approach. In this worksheet, Par Forward, column F derives these outright forward rates for each maturity from the stated FX spot rate of 215 and the yield curves for the two currencies appearing in columns D and E. It quickly becomes apparent that the large interest rate differential between the two currencies causes each successive forward to become weaker than the one preceding it, resulting in the net cash flows in US dollars received at settlement by the US company to diminish substantially over each quarter. This might give rise to the appearance that the company is becoming less profitable over time, even though the real problem here stems entirely from the large interest rate differential and has nothing to do with the company's operating performance. The treasurer would logically prefer to see a single forward exchange rate at which she could exchange all her real receivables. The Par Forward solution makes it possible for her to smooth out the uneven dollar cash flows that would result from using the outright forward rates, and is constructed simply by solving for the single rate that would generate cash flows in US dollars whose present value, appropriately discounted, equals the PV of the unequal stream of cash flows in this column H. The worksheet solves for the par forward rate by constructing an additional column, column I, based on a guess that the par forward rate is 2.5, then calculating in column J the difference between the cash flows in columns H and I, and finally calculating the PV of the difference and adding them together in cell K10. This PV difference turns out to be just over $1.5 million, suggesting that our guess is quite significantly removed from the correct number. We now use GoalSeek to make this PV in cell K10 equal to 0 by changing the number in cell G12. Thus, set cell K10 equal to value 0 by changing cell G12 and hit OK, reveals a par forward rate of 2.2820 in cell G12. Therefore, instead of going long dollar real outright at the different individual rates shown in cells F6 to F9, the treasurer has locked in a long dollar real hedge using a par forward rate of 2.2820 for all 4 value dates, resulting in smooth dollar-denominated receipts on a quarterly basis that appear in this column I. This is a good time to conclude this chapter and to ask you to test yourself by answering the 6 quiz questions coming up next.